Okay, so let us look at this and second part, okay, of this transpirations, where we're going to look at the rate of the transpirations and also how this external factor affects the rate of transpiration. So generally, we are going to focus on to these four factors. External factor. External factor means something that we can change. It's just external, means the outside of the lip. For example, humidity of the surrounding environment, the temperature of the surrounding environment, the air movement of the surrounding environments, as well as the light intensity. Okay, now when you describe how these factors affect the rate of transpiration, always think about first thing, the steepness of the water potential gradient. Okay, the higher the steepness, the higher the rate of transpiration. Are you clear? Always remember. So which one apply? Which one actually apply? Humidity, yes. Air movement, yes. These two always link it with the steepness of the water potential gradient. Temperature always link it with the kinetic energy. Light intensity, we link it with the opening of the stomata. Okay, so how we explain? Now, look at this, humidity. So we do know that when I increase the relative humidity, transpiration rate actually decreases. Now, why this thing happen? Always think about this. Very simple. Okay, very simple idea here. Now, humidity actually refers to the number of water vapor. You try to imagine, I keep you guys in this room. Okay, you guys in this room, you guys are water vapor. Okay, try to imagine that you're saturated. Outside, okay, for example, you guys finish the class already, you want to move out from your class, but outside also have many people, many students waiting to enter. So difficult for you guys to go out, right? So because more people outside, we say that increase the humidity. Can I see that analogy in this case? So you try to imagine you are inside the room, you want to go out. Why you cannot go out? I mean, we put inverted comma here easily, because why outside so many people block you? Correct or not? So means that when you increase the humidity, you increase the number of the water vapor outside. So therefore, the steepness of the water potential gradient is low. Or vice versa, when you have a low humidity, the rate of transpiration is high. Okay, so low atmospheric humidity, due to what? Due to the low number of water vapor, increases the steepness of the water potential gradient. So when you increase the steepness, therefore you increase the rate of the transpirations. Okay. Second, how about temperature? Temperature actually something like heating process, kinetic energy. So, okay, so more kinetic energy means that you guys will move. We try to imagine inside a room. Now I burn the room. Okay, I heat up the room, so hot in the room. Then what you're going to do? You're going to escape from the room, right? You're going to run, okay? So when you run means your kinetic energy is higher, so higher chance for you to escape. So same goes to the water vapor. When you increase the temperature by heating process, direct heating from the sun, therefore what happened here is the kinetic energy gains by the particle or this water vapor is high. So therefore, you can see that increase. Okay, the temperature indicates that there is an increase, okay, in the kinetic energy. So therefore, the movement of water vapor in the substomatal cavity will be high. And water vapor move out through the higher rates. So therefore, the rate of transpiration also increases. And generally, high temperature also reduce the atmospheric humidity. Okay, now don't worry about the plateau here. Okay, don't worry about the plateau. Okay, I will explain it later. Okay, now next. How about the air movement? Okay, air movement is something like the guards. Okay, move away the student outside of the room, so easy for you to move out. Try to imagine. Air movement is something that the guard or the discipline teachers, okay, move outside the classroom. You guys cannot stay outside. You must follow SOP. So remove the student outside the classroom. Easy for you to go out, right? Okay, so therefore air movement reduce the humidity. So in this case, moving air carry away the water vapor outside the stomata. So this creates a steepness, a steep water potential gradient. Okay, so the rate of the transpiration increases when on windy conditions. Okay. How about light intensity? Light intensity actually correlates with the photosynthesis. So when it increase the light intensity, will stimulate higher rate of photosynthesis, because we want to allow more CO2 to diffuse into the leaf for photosynthesis. Therefore, inevitably, we increases the rates of the transpirations. Are you clear? So if you follow the graph here, you can see that the transpiration, can you see that? The transpirations increase, it follow the shape of the light intensity. And why? Because of the photosynthesis. So in general, if you summarize in this case, okay, I summarize. So first of all, if you look at this humidity, so when you increase the humidity, okay, so decreases the rate of transpiration. Okay, when you increase the temperature, we increase the rate of transpiration. If we increase the wind speed, okay, so we increase the rate of transpirations, and we increase the light intensity. Against, we increase the rate. So how we explain in general? So humidity decrease the rates. So because we decrease the steepness of the water potential gradient, temperature because we increase the kinetic energy in this case. Okay, wind speed, we decrease the steepness. Sorry, wind speed increase. Okay, sorry, my mistake. Increase the steepness. And the light intensity because of the increase of the rate of photosynthesis. So mean increase the opening of stomata. Okay, so this is in general. Okay. Now, not only internal factor, we do have external factor, we do have the internal factor as well. So what are the internal factors that can affect the rate of the transpirations? So these two highlight the leaf surface area and the number and distributions of the stomata. Where is this, or where are these stomata? Okay, so generally, if the leaf surface area is high, because we still have to understand that if the leaf surface area is high, okay, because of the evaporation from the leaf surface. Clear or not? Okay, and also generally, if the leaf surface area is high, the number of stomata will be more. Clear or not? Okay, so what we're going to study here is, first, we're going to look at this leaf surface area, followed by the number and distribution of the stomata. So first thing we're going to study here is the stomatal density. So basically, what means stomata density? Stomata density is defined as the total number of stomata per unit leaf area. Okay, so it means that per mm squared, for example. And the stomata density will be different if you look at the different species. Okay, if the stomata frequency or stomata density is high, either you use stomata frequency or stomata density. If the stomata density is high, then we know that the rate of transpiration will be higher because of the opening. Okay. However, the transpiration also depend whether the stomata are open or closed. So this actually answer the question here. Why plateau? Because you try to imagine that most of the transpirations occur at the stomata. If we don't increase the number of stomata, then you can see that the rate will remain the same even though we increase the temperature or the air movement. Correct or not? So the limiting factor here will no longer the air movement, no longer the temperature, but the limiting factor here will be the number of the stomata and whether they open or not. Are you clear? Now, if you continue to increase the temperature for a long period of time, you will see that the rate of transpiration will decrease. Air movement also. Why decrease? Because the stomata closure due to a hormone called ABA. ABA is a hormone that actually released when the plants experience water stress. Okay, this one we're going to learn in A2. Okay, so now they'll control. Okay, so but stomata density cannot be controlled. Are you clear? You cannot decide, oh, I want to have 10 stomata density. I want to have 20 stomata density. Impossible. Okay, but we can study the effect by looking onto how the distribution of the stomata and the stomata density affect the rate of transpiration. So if you want to study this stomata density, we can do two ways. One is epidermal peel, another one is epidermal impression. So what's the epidermal peel? We have done this last week, epidermal peel. Okay, the leaf of the onion, we peel out the inner layer, kind of inner epidermis. So this peeling is known as the epidermal peel. So we peel out and then place it onto the slides. We will be able to view how many stomata per area. Okay, but sometimes it's difficult for us to peel out this epidermis because they stick, okay, to the second layer of the cell. So when the peel out, we may not be able to do this. We can do what we call the epidermal impression. Okay, so what's the epidermal impressions? Let us look at this diagram. So you have the leaf. We something like make a rubber stamp in this case. What we're going to do here, we apply a layer of the nail varnish. Okay, nail varnish. So you can see that the nail varnish. And then we can use a cellophane tape or transparent tape, stick on this area, and then we peel it out. So because of this nail varnish, the nail varnish actually we're going to have the imprint of the stomata. So when we place it on the slide and we say, can you see that? Okay, we peel out and then we place it on the slide. Then we can actually view it here and count the number of the stomata. Are you clear? So this process is known as the epidermal impression. Okay, so it's something like do a mold. Okay, basically you apply the nail varnish and then let it dry, and then you stick. Can you see that? What you stick? You stick a layer of the transparent tape, and then you peel it off. You can see that the imprint already here. Then we can just stick it on the slides and then view it. Okay, so the stomata are open or closed or not at the point in the time the peel of the impression was made can be observed under a light microscope. Okay, so let us learn how to estimate the stomatal density. Okay, so let us look at this figure 8.5. So figure 8.5 shows a stage micrometer viewed through a microscope on the power of 40 times with the eyepiece graticule. Okay, so each division on the stage micrometer is hundreds of micrometer or 0.1 millimeter. So using the formula of the area of a circle, pi r square, where pi equal to 3.14, okay, and r is the radius of the field of view. Okay, so show you're working how you calculate the area of the field of view. Now, this is quite interesting question. I want you guys to try. So take 5 minutes to calculate the area of this white area. Are you clear? This white area is termed as, okay, area of the field of view. Okay. Now, sometimes question may provide you guys more information than what you need. So you have to actually select the information. So for example, in this question, we do not need to have this eyepiece graticule at all. You do not need to calibrate the eyepiece graticule also. Useless, okay? Because why? Even though you use entire thing from 0 to 10 here, you do not know, okay, the whole diameter. So only can you see that we align the stage micrometer. So means that what is the diameter? So because each of them 0.1 mm, 0.1 and 0.1, so means that I know what is the radius. Okay. So first question answer here, we calculate. So what is the diameter? Diameter of the field of view equal to, okay, 3 divisions, and each division is 0.1 mm. Am I right? 0.1 mm. So therefore, the diameter is 0.3 mm. So I know what is radius. So you need to show a calculation. So radius equal to half of the diameter. So therefore, radius is 0.15 millimeter. So what is area? Area equal to pi r squared. So pi is 3.14. Radius is 0.15. Okay, mm squared. So therefore, if you calculate 3.14 multiply with 0.15 square, you will get the answer 0.0707 because 3 that are significant figure. So answer 0.0707 millimeter square. Okay, so area of the field of view 0.0707 millimeter square. Okay, so if you look at the figure 8.6, the same field of view, so means that the area here is equal to 0.0707. So therefore, you can actually now count and record the number of stomata in the field of view, and you have to mark on the above diagrams the stomata counted and calculates the number of stomata per mm squared. Okay, so let us count. I use a different color. So this, okay, count it, number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so I got 28. Some of you may got 29, okay, because of some here. Okay, so I got 28. Okay, so first, to answer questions, so number of stomata in the field of view. For me, I got 28. Okay, I have 28 stomata. So what is the area? So we say that there are 28 stomata in 0.0700 mm square of area. So therefore, number of stomata per mm square will equal to 28 divided by the area 0.0707. Okay, so 28 divided by 0.0707. Sorry, 28 divided by 0.0707. So you guess, I mean, answer 396.0 something, kind of. But it's number of stomata. Number of stomata must be full number or whole values. Okay, so answer I have here is 396. So answer number of stomata per mm square is 396 stomata. Okay, so this is how you calculate or you get the stomatal density. So means that in this area is 0.0707. I have 28 of them. So means that per mm square, so divided by the area, you get the total 396 stomatal per mm square. Okay. So if the stomata density is constant between two plant species, then we only need to look at the leaf area. The higher the area, the more the stomata. So in some species, for example, dicot, okay, the stomata only located at the lower leaf surface because a higher leaf surface temperature is higher. So therefore, you're going to have higher rate of transpiration. In order to reduce the transpirations, therefore, some species like dicot leaf, dicot plants, their stomata always located on the lower leaf surface or lower epidermis. So this is very important. Long period of light, heat, or dry air could result in a decrease in the transpiration due to the stomatal closure. So many plants are able to regulate their stomata under water stress. So I didn't give you guys the detail about this. So when the plants experience water stress right now, they release a hormone called ABA hormone. Okay. This ABA hormone can cause the stomatal closure. Because plants cannot afford to lose too much of water. Are you clear? You cannot. So therefore, these ABA hormones, when the plant release this hormone will result in the closure of the stomata. Therefore, you can see that the rate of transpiration decreases. Are you clear? Even though the temperature, for example, the wind speed increases, because we can't actually allow or the plant allow too much of the water because the supply from the soil is insufficient to meet the demands of the plant. Okay, so therefore, if the rate at which water vapor is lost by transpiration exceed the rate at which the plants can take up the water from the soils, then they can close their stomata, reduce the transpirations and also the water loss. Okay, so with this, I've done for the factor affecting the rate of transpirations.